Viewers, ladies and gentlemen, welcome once again to the series of our lectures, our cascade in this channel. Today we are going to be talking about one kind of element, one problem, one disease that is quite common among not only our people, but it's a general universal issue. And that is the problem of what is called in science or in medical science hyperuricemia, that is uric acid deposition, or in the general term, it is known as gout, G-O-U-T. For us to have a very good understanding of what gout or hyperuricemia or uric acid deposition is, we need to have a very good understanding of the origin of uric acid as it comes or relates to, the metabolic processes that involve purines and DNA. Now, we need to first of all understand what is DNA. Many people, when they hear the name DNA, they only understand the letters D, three letters DNA, but they don't understand or they don't know because of the fact that they are not from science background or from medical background. They don't know the full meaning of DNA. DNA means deoxyribonucleic acid. And DNA is the structural molecular component of our genetic constitution, our hereditary constitution that carries the genetic, mapping of the ancestors that is passed to the offsprings. So that is a simple definition you can give to a layman for him to understand what DNA is. But in this lecture or in this cascade, I'm going to give us, a basic understanding of what constitution or what constitutes or what comprises a DNA structure. A DNA structure consists of a building block. And a building block here means that there are many building blocks that bring or come together to produce or to form a DNA structure. And these building blocks are called nucleotides. And a nucleotide is nothing but a ribose sugar. Remember when we had our discussion or our cascade on glucose, on polysaccharide, on disaccharide, we mentioned that glucose is a cis-carbon sugar, it's a hexose. But here in this lecture or in this cascade, we are talking about a sugar that is not cis-carbon, it's a 5-carbon sugar. It is called ribose sugar. This ribose sugar, which has 5 carbon atoms, when it comes into bonding, or when it bonds or it binds, it comes into bonding with, a compound called a nitrogenous base. It becomes what is called a nucleoside. So what is a nitrogenous base? A nitrogenous base can be a purine or a pyrimidine. When I say purine, I'm now talking about, the occurrence of a compound that has 2 rings, one ring from pyrimidine and the other ring from imidazole, fusing together, coming together to form a purine compound. It's a 2-ring carbon nitrogenous compound. That is a purine. And this purine can either be adenine or guanine, while a pyrimidine can be, or let me say, a pyrimidine is a single cyclic carbon nitrogenous compound. So that one can be a thymine or cytosine. So while purines are adenine and guanine, pyrimidine are cytosine or consist of cytosine and thymine. So these 2 or these 4 are nitrogenous bases. These nitrogenous bases are the ones that will come in combination or in reaction or in bonding with the ribose sugar I mentioned earlier. When a ribose sugar binds with a nitrogenous base like adenine, for example, from purine, it becomes a nucleoside. The combination or the binding happens on carbon 1 of a ribose sugar. So since a ribose sugar has 5 carbon atoms, on the 5th carbon atom, if a phosphate comes and binds with the ribose sugar, it now the whole structure becomes a nucleotide. So a nucleotide is a molecule or is a building block of a DNA that constitutes or that comprises of a ribose sugar that binds with a purine like an adenine or a guanine or a pyrimidine binding with a pyrimidine like cytosine or thymine on carbon 1. And then at the same time, binding with a phosphate on carbon 5. So once a ribose sugar achieves this combination, or I mean this binding, or this bonding, I mean, it becomes a nucleotide. Now this nucleotide, as mentioned earlier, is the building block of DNA. So when you have multiple nucleotides coming together to form a long strand of many nucleotides, binding between one nucleotide with the neighboring nucleotide through what is called a phosphodiester bond, you have a long chain, a linear chain of a DNA structure. On the other hand, on the right-hand side, you could have another DNA long chain, of nucleotides in a parallel, anti-parallel direction, upside down, now also binding with the other one that I mentioned earlier. So when you have two nucleotides, long chain of nucleotide strands or DNA strands coming to bind through their bases. The base on this side, on the right side, and another base on the left side, like adenine on the left side, binding with thymine on the right side, or guanine on the left side, binding with cytosine on the right side. You have, this bonding occurring through hydrogen bonding, and this now forms an alpha helical structure of a DNA. So much about DNA. Now, how do we bring or how do we factor in our discussion on gout? That is hyperuricemia. Now, since we mentioned purines, now this purine is quite available in our DNA, as I mentioned, and so it is also available. It's cheaply available in red meat, like the meat from cows and other animals like pork. So this red meat has very good concentration of purine, the base purine, like adenine. So because it is a substrate or it's a compound or it's a substrate, is going to go through catabolism, through the normal metabolic pathways where enzymes will come and change this purine, adenine, to its last substrate. And in this process, many enzymes are brought in to, continue the process one step after another until the last product or the last substrate is formed. So as it goes along on the pathway, substrate like hypoxanthine will be formed. And then, of course, after hypoxanthine, xanthine will be formed through an enzymatic reaction, and then uric acid will be formed. This uric acid, or urate, is crystalline in nature. Crystalline and also is spiky, very spiky and crystalline. So if it is not converted to its soluble form, which is called allantoin, through the activity of an enzyme called uricase or urate oxidase, the problem is that the conversion will not happen if that enzyme is not available. So in some humans, about 1 to 2% of the world population do not have the enzyme uricase or urate oxidase that is supposed to convert this uric acid to allantoin. And I told you allantoin is the soluble product which is supposed to be obtained from uric acid. And once it is obtained, it is excreted through urine. But in the case that the enzyme uricase is not available in some humans, now uric acid deposits, which is not converted to allantoin. So once it deposits in the joints and other parts of the body, especially on the foot area, it begins to cause a lot of pains through, problem associated with arthritis. So this brings a lot of pains to people that have this problem. So in other words, what you are trying to say is that uricemia, hyperuricemia, is about uric acid deposition. And people that take a lot of red meat should be careful, because once it accumulates, and if they don't have this enzyme that converts it to allantoin, a lot of problem will come in. So follow us in our next lectures or our next cascade. We are going to cascade to so many other things associated with this. Subscribe our channel and follow us through. Thank you for listening.